This presentation is going to be talking about building predictive web apps for business, and it's something that we've just launched a new course called Shiny. It's called Predictive Web Apps for Business with R Shiny. So it's going to be very closely related to that, but we're also going to talk about a little bit of other information too, and it's going to be really focused on helping you grow. So with that said, before I leave this slide, David, would you mind introducing yourself?
Oh, sure. I'm David Curry. I own a company called Sure Optimize, and we focus on marketing analytics and search engine optimization.
Okay, cool. Thanks for that, David.
Yep.
All right. So what I'm going to do here is just talk a little bit about myself for those that are new in the audience and that may not know me. So my name is Matt Dancho, and what I've been doing over the past 2 years, I've done quite a bit in the art community. I've been focused on number one, starting my own business called Business Science, and then also really finding interesting ways to give back to the community. I'm very passionate about the data science community as a whole. One of the ways that I love to give back is through developing software myself. And I've created a few R packages here, TidyQuant, Sweep, TimeTK, Anomalize. A lot of them are related to my two passions, which is time series and which is also finance. So that's one of the ways that I just like to, and it's something I enjoy as a hobby. I'm also an educator, and I think you'll learn a little bit more about me as this talk progresses. But what I do now is I teach data science through our university called Business Science University. Okay. Next, I just want to give you guys a perspective of where I came from as a data scientist. And I think this is important for this talk, especially because we're going to be talking a lot about production, a lot about data science, but I want to give you a perspective of where I'm coming from so you understand kind of my worldview. And I'm thinking it's probably going to match your worldview as well for many of you that are joining the call today. So this is my journey for becoming a data scientist. And I think it's somewhat embarrassing to be honest, because I'm up here, talking about teaching data science and how to do, production. But I want you guys to know that I struggled with my own learning path when I was initially starting data science. It took me a really long time to learn basic skills. There's a lot of reasons because of that, but one of the main reasons was because I was having a difficult time connecting the data science tools that were out there and the education and the course options and things that I was learning to my day-to-day job, and also my investing passion, the things that I was trying to do. I was having a really tough time being able to do them. And it was making it very difficult to transition for myself at that point where I was utilizing Excel a lot. So learning R was actually a little bit of a challenge. So the thing that helped me the most was actually when I stopped doing what I was doing, which was just taking a lot of courses at the time, and then also just kind of scouring the internet for information, and really focused on building one specific thing, which was this R package called TidyQuant at the time, and it was my first R package that I ever built. And it was a challenge for me, but it was a really exciting challenge because it was something I was passionate about, finance. It was something that, I didn't have a clear game plan for what I wanted to do with it, but I had these two kind of competing technologies, one being the Tidyverse and another technology being this other system in R called XTS, which was a different time series system. And QuantMod and some of these other packages were built on top of that. You may not understand what any of that meant, but to me, as I was learning, I was having a really difficult time utilizing, some of these R packages that are really popular, like ggplot2 and dplyr, with my financial analysis. So my solution was this R package called TidyQuant. And what I did was I just stopped what I was doing, basically learning, and I started building. and I built this R package. It took me about 2 months, but honestly, in that 2 months, I learned probably years worth of knowledge if I was taking courses or something like that, with the options that were available at that point in time. So so really that led me to kind of the next step was, you know, my game plan to, and why I do what I do is, it's really because I don't want to see you follow the same, have the same struggles, have some of the same issues that I had when I was first learning. So this conversation that we're having today, it's all about you. It's about helping you grow. It's about, there's a lot of things that are out there, a lot of options that are out there, and it's a very challenging and a very rapidly changing environment. So I want you to be able to really not have the same struggles that I had. So um, I did create a system. It's called Business Science University, and it was really born out of these challenges that I was having when I was first learning. And since building this university, it's really been an eye opener, because it's I've been fortunate enough to have the opportunity to really help so many data scientists that are out there that are kind of at that point where they're struggling, or they're just not being able to connect the data science to the business, or they're it's taking them too long to learn the simple the simple concepts that they want to learn. And the system that I've developed, my background's engineering. I actually have an engineering degree, and it's really being able to, what that has helped me be able to do is, in my career, has been to be able to come up with systems that kind of streamline processes and make things work better. So what I did was I applied that to an educational system, and that's what Business Science University is. So I've integrated the things that, from that process of uh, building TidyQuant, to that process, to having that singular project that I was working on, to focusing on less on teaching tools and more on teaching how to integrate those tools as you're trying to progressively, build something. And then also some of the best practices, like building repeatable frameworks, giving people straight, very systematic approaches to solving these problems that they can then apply to their own project, which is going to be different than what I teach them. But it just ends up being a good way for, a system that they can then repeat. And then also providing mentorship. That's the other key piece that I wanted to do with Business Science University, was to be able to develop something that, it's not just you out there on your own, but having somebody to be able to bounce ideas off of, and really have a community of support to help you grow. So this talk is all about helping you grow. I know you're here to talk about, or we're all here to talk about data science in production and building web applications. But I think that this kind of gives you my perspective of why we're having this talk right now and what we're trying to do with this talk, which is help you grow. All right, so the agenda for today is, it's again a jam-packed agenda. We're going to be talking a lot about this new kind of term that I'm starting to come up with, and I think it's probably been out there before me, but I've adopted it. It's called full stack data science. So we're going to be talking a lot about what that means to you, and really, more importantly, what it means to the business, and how you can utilize this as something that you can use in your own organization to accelerate the organization and generate ROI for it. We're going to talk about some examples. We're going to do some product demos. We're going to talk about the application building process, which is when you want to productionize and want to build one of these data products, which is a web application. How do you go about building that? And then at the end, we're going to talk about how I can help you to really be able to ensure that you transition into a full stack data scientist which I believe is the future. And I think others would agree with me as well. And we'll see some evidence of that. Okay. So with that said, I'll start off this talk. The data science workflow is what I go back to. This is something that I put together a while ago, and it really kind of maps out the entire process of solving problems with data science, where you start with a business problem over here, and you kind of go through several stages where you're first preparing data, then you're doing some experimentation, and then you're doing distribution, and then your output is business value when you deploy something. And that's normally a data product, whether it's an application or whether it's a report that somebody can then utilize to gain information from. So there's a lot of different sub steps in here, and there's you can see that it kind of goes, there's a little bit of repetition because you don't always get your insights right away, but you need to be able to very comfortably work through this data science workflow. The next slide here, what this does is it showcases some of the tools, and these are what I call the 80-20 tools, which are the core tools that I personally use all the time. And this is what has enabled me to be very successful in my career, but also to be able to not have, to not take so much time that you're learning every single tool that's out there, but you have a defined set of tools that you can utilize to solve about 80% of your problems that you're going to face. And the end result, which is what we're going to be talking about today, is in this blue box here. And what that is a web application that integrates a lot of the tools and the technology and the machine learning and the things that you're working on learning into a package that you can then distribute throughout your organization. So that's what we're going to be focused on. Okay, so this term full stack data science and full stack data scientist, being the person that is in that role of being able to integrate all of these different tool sets. Where does that come from? Why am I talking about it now? What is this, what am I seeing out there that is leading me to believe that this is the future? Well, my opinion is that the environment is changing. I've seen this through evidence, and I will show you a little bit of that evidence. But it's been mainly working with some clients that I work with, and also it's been some of the things that I've been seeing through what most jobs are now transitioning to be looking for. So in the past, in the very recent past, what most companies were doing was they were hiring data scientists to be able to build a data science practice, and they were primarily leveraging those data scientists at the leadership level, which is where these data scientists would build these predictive analytics products, mainly reports, and they would provide those to the leadership, and then the leadership would kind of utilize those predictive insights to be able to better, change their own, kind of groups within the organization. And what I call that is centralized predictive intelligence. So that's where these leaders are primarily holding on to that predictive insights, and then they're utilizing it to be able to kind of adjust and pull levers on their within their own groups in the organization. So now what I'm seeing is that we're transitioning. We're going through this transition where we're now moving to productionization of data science. So what the demands are on the data science practice, that the organization wants to accelerate products, these data products, being pushed into production, so that way it's more scalable. And what the organization is seeing is that the leaders can't access everything and everyone and do the jobs of everybody. So, but what can happen is the data science group can develop these analytics products as web applications that everybody in the organization can interface with. And that's a very scalable, and it's able to be integrated then at all levels of the organization, not just leadership. And the main benefit is that this maximizes the ROI, the return on investment from that data science practice, and it helps propel that organization into growth and into being able to do a lot of things. So what I call this is scaled predictive decision making. So it's not just the leaders that are centralized. They're now moving to scaling that analytics and providing it to all levels of the organization. So what evidence do I have of this? Well, one of the, besides the clients that I'm working with that also I'm seeing this evolution happen internally, I also see externally some things happening, which is on LinkedIn. One of the things that they do is every year they put together a list of the most important skill sets. And I think this is telling, because when I looked at this, I saw that out of the top 20, just in the top 6, we've got the first 3 are related to data science. So we've got cloud computing, artificial intelligence, and analytical reasoning. And then the 5th and 6th are related to web applications, UX design, mobile application development. So basically, what this is saying is data science is very important right now. It's a high demand skill. And then so is the ability to produce web applications either via mobile or on computers. So you combine those 2 skill sets, and then what you get is full stack data science, which is this group here down in the right hand corner of a team of data scientists that are able to build these predictive web applications that can then be distributed through the organization. So what does that look like? So that looks like this team here makes these web apps, and those web apps can go to different areas in the organization. So this first one here is a predictive web app that's a sales dashboard. It's a take on a sales dashboard, but it actually has machine learning under the hood that is being able to generate this forecast here. Maybe a little tough to see, but that demand forecast, which is what that is called in an organization, can then be distributed to sales, can be distributed to marketing, can be distributed to operations, and all of these groups can then utilize that data to be able to help with their planning and help to understand which customers to focus on and when issues arise and so on. This next app here is another one that this data science practice has developed. And what they're doing is they're modeling the product portfolio, which is all the products that company makes. And what they're doing is analyzing for gaps, which is where there's not a whole lot of products here. And then what they're doing is they're using machine learning underneath the hood to be able to price new products and come up with different product prices based on this existing portfolio. So what the user would do is adjust some of these inputs, and they would be able to output a new product. And then that can be utilized by the marketing group for them to be able to see which products should come to market, and then also R&D, research and development as well. Okay. So the organizations out there, we're transitioning. We're seeing this transition. I'm seeing it with the clients that I work with. I'm also seeing it with many of the some of the information that I'm seeing out there from like LinkedIn and Indeed and some of these other areas. So at the end of the day, there's got to be some organizational benefit though to building these apps. It's not just for the sake of doing it. What is that? And what I'm seeing is that there is this generation of what's called return on investment. So the organization, when it builds a data science practice, it invests in that group to add people to that team, but that team better be able to generate business value. So how they're justifying it is through these applications. So a typical example, or a very good example, is this thing called the demand forecast. So many organizations, are just doing this based on a 3-month rolling average. And this demand forecast is really important to get it right, because what ends up happening is all the different, it drives every part of the organization, from manufacturing, from inventory, from planning, to supply chain, working with vendors. So if you don't get this demand forecast, meaning how much product are your customers going to purchase in that next month to 2 months, then it throws all of that process off. And that can be very costly, because you end up hiring too many people, overstaffing or understaffing. You end up not having too much inventory on hand, or worse, not enough inventory, and have to pay extra money for very quick or short runs of material. So it ends up being a very critical thing to get this demand forecast right. So what we're seeing is that using machine learning and using different techniques where we're able to integrate these new tools, data science, with the existing methodologies that the companies are using with working with their customers and providing feedback as to what's going to be purchased in the next few months. We're able to see that improvements of 20% or more in terms of reducing the error are not uncommon. I mean, this is totally achievable. And it's actually not a very high bar, because the 3-month rolling average is a pretty easy bar to beat. So just to give you an idea, an organization that generates about $1 billion a year in revenue, with their error decreased from 20% to 15%, which is a 25% increase in accuracy, creates about $50 million per year closer to the target. So that $50 million means we've just subtracted out $50 million in potential error. So that returns about 30% or so in terms of just kind of a rule of thumb to generate about a $15 million savings for that company, because they're able to better plan for people, they're better able to work with their supply chain, they're better able to just be more efficient as an organization for an organization that so for a data science team, generating $15 million per year from that team just off of an improvement of the demand forecast is totally achievable for an organization that earns about $1 billion in revenue per year. So definitely a lot of savings, and it's through these things called applications, because that's how you distribute it through the organization. All right, so now we're getting to some of the fun stuff. I want to showcase a few of the applications that I've personally built and some of the applications that I teach at Business Science University, so you can see firsthand what these applications look like, and then we'll talk about how to build them, and then also show you some of the courses that we have. So basically, in a nutshell, deploying apps scales better decisions. And what we're seeing here is that apps like these that can be built by the data science team for an organization that earns about $1 billion a year, apps like these can save 20 million, 5 million, 5 million, 15 million per year if they're deployed, and then if you train the people up in the right ways to be able to utilize those. So I'm going to focus on this one and this one. So the first one is going to be this demand forecast app, which has a sales dashboard where we've got sales by geography, sales by time, and then this time series also has the demand forecast, so a forecast mode, and this is and we'll play around with that. Just to give you guys a heads up, high level overview, the skill level to build this application, this particular application is intermediate, beginner to intermediate. The build time is about 3 hours is what it took me to build and to integrate some of the different analysis that I've done. And then some of the tools that I use to do it: Flex Dashboard, Shiny, Plotly, and Parsnip and XGBoost for the machine learning. Okay, so I'm going to open it up, and this is what it looks like. I have it in dark mode, so there's actually a light mode, which just kind of changes the appearance to it. But basically how it works is we've got underneath the hood here, we have XGBoost running. And the reason I'm using XGBoost and not some other types of technology like Arima or some of the other packages that are out there for time series is this one's much faster and it's pretty accurate. At least with shorter horizons, it's pretty accurate. So you can see here, this is a weekly aggregation. We can go to monthly as well. And if I change this to 12-month for the forecast horizon and hit the apply button, we can see that it updates almost instantaneously. And what you didn't see behind the scenes is this algorithm actually trained on the new data, and then it processed that, it performed that training inside the app, which normally can take a long time, especially if you have big data. and it generated a new forecast. So what that allows me to do is I can actually do cool things like just look at, say, one subset of the products. So I'm going to look at over mountain bikes. And if I hit the apply button, generates a brand new forecast for me. And it was lightning fast too. So I'm using XGBoost under the hood, and it's being able to build this. I can then change it, the periodicity, to weekly. And if I change this back to 52 weeks, I'll get a full year. And we can see that it's got that seasonal pattern to it and everything. So it's doing a pretty good job. But most importantly, I mean, most important is the performance. But secondly, it's got a good user experience to it because they aren't having to wait a very long time to get pretty accurate results. And it's much better than the 3-month moving average. So, and it's very flexible. So anybody that knows how to, use these drill downs can then be able to drill into different products and create forecasts for those particular items. Okay. So that's the first one that I wanted to show you. I'm going to go back to the slideshow. And the next one that I want to show you, this one is more geared towards a financial company. The skill level for this, so this is a financial portfolio optimization tool. And the skill level for this app is expert. It took me about 2 days to build it. And that was all the technology that runs under the hood. And then also the framework. This one's built using an actual web framework, which is called Argon, and then utilizing some of the other technologies like Shiny as well, so you can integrate R with it. So this app is available right here. I'm just going to, I'm going to click this, and that'll link me to it. So it's getting pulled up right now. While that's loading, I just want to give you some background. So this application is geared towards, think of like a portfolio asset manager at, say, a hedge fund or at a mutual fund, for example. They want to understand what combinations of stocks to, and more importantly, how to divvy up the funds amongst those stocks to best generate return on their investment. So what ends up happening is if they end up having a bad month or a bad quarter, they end up losing a lot of clients. I think on average, if that stock dips more than 5%, or excuse me, if that mutual fund dips more than 5% below the S&P 500 index performance, they end up losing a lot of their customer base. So it can be disastrous for a mutual fund to take on, a higher performing portfolio. If they have one bad month, they could potentially lose a lot of their clients. So being able to manage risk is very important. So what this app does is it creates, it allows the asset manager or the mutual fund manager to pick their stocks, and then they click the calculate button. And what it does underneath the hood is it develops this 3-dimensional plot where it shows them which stocks have the highest Sharpe ratio, which is a measure of risk to reward. And it tells them then how much of their money to dedicate to each one of the stocks to maximize that Sharpe ratio. And then also what it does is if I click over here, we can see how that portfolio does over time. And we can compare that to the S&P 500 index, and we can see that this portfolio is performing much, much better. And then it also has some settings, and we can actually adjust how many random portfolios that we want to generate. And that we can turn off reproducibility. We can adjust the time range and so on. So this app, again, is an expert app. You can see that it's built using an actual web framework called Argon. And it's definitely something that's going to be a little bit more time consuming to build. But the benefit is that you've got a higher end app that can be customer facing, or it can be even used internally, and it's just a great looking app. Okay, so those are the two demos that I wanted to show you.
Hey Mac, can I jump in real quick? We had a question earlier. I forgot who it was from, but they were asking when should you think about creating a web app versus an API with sort of Plumber? And I think this is probably considering your requirements, I would imagine.
Yeah, so Plumber is a great way. It all depends on what you're trying to do. If you're going to be interfacing with, say, mobile technologies, or if you're going to be interfacing with Python, or if you're going to be interfacing even with Excel. And I know a company that's doing this right now. They're actually using Plumber under the hood to connect up with Excel. That way you can leverage your data science with all of these different technologies at the front end where the user is. So if you say you wanted to build a mobile app that used R, you do that through a Plumber API where that mobile app would then connect up to Plumber. Now, for a lot of what we're talking about, so mobile is important in certain situations, but for a lot of businesses, they're going to be sitting at their desk, and what you can do is you can have a system set up where they have a grid of apps. Maybe they have like the portfolio app that we just talked about. Maybe they have another app for analyzing some other aspect of their job. You can containerize those just with having kind of shiny apps that they can pull up and they can interface with right on their desktop. So like I said, it's all related to your goal. But what I would do is I would think about how your user is going to be utilizing your data science.
Yeah, and if you're going to have multiple applications utilizing your data science models, then that's kind of a good candidate for an API.
Yep, exactly. Okay. All right. So we're back here in the presentation. Those were the two demos that I wanted to showcase to you. One's kind of an intermediate app, again, 3 hours to build it, but it doesn't have the same kind of user, what I'll say is UX or UI, not the same design level of the other app. So it all depends what you're going for. What does the app build process look like? So this is something I wanted to show you guys so you can kind of understand and see what it takes to build one of these apps. So this is us kind of starting out. It all starts within the RStudio. If you're building it through R and using the tools like Flex Dashboard and Shiny, it starts with the RStudio IDE. You're going to build. You're actually going to make, if you're making this sales dashboard using Flex Dashboard, it's actually using R Markdown, and it's set up to run Shiny and Flex Dashboard, and it's just a normal R Markdown document. You're going to load in your libraries and you're going to add your code. And then it's kind of an iterative process. So how I teach Shiny and how I teach Flex Dashboard, especially to beginners, is we kind of just step down through it. So the first thing we're going to make is just something very basic. And we're going to get the layout of having an app with just maybe one of the visualizations that we want to accomplish with that particular app. So the technologies that we're using here, we're using Flex Dashboard. We're taking that sales data, importing it into that app in RStudio, and we're creating one visualization, which is Plotly, and it's just an interactive app that, but it doesn't have any user inputs at this point. It's very basic. It's just honestly a map that you can kind of see in a web browser. So what you do is you create that layout, and then you add your data, and you figure out a way to visualize it. And we use Plotly to visualize this particular data set. Okay, the next piece. What you then do is we start to think about what do we want to add into it, and how is that user going to be able to interface with this data. So we start adding things like, well, maybe that user is going to want to be able to kind of pare down that data or filter that data. So how are we going to do that? Well, we're going to add a new tool called Shiny to that Flex Dashboard app. And what that's going to allow us to do is to create these user inputs. And we're able to create all sorts of different inputs. These are kind of like check boxes. This one's like a drop down, and you can select different items. This one is just a button you click and it resets. And then it has some logic that drives the data representation here in this map. And that's all done using what's called reactive programming and with Shiny. Then we start to add a little bit more complexity to the app. We start to then build out that dashboard, kind of thinking that the end goal then needs to be, hey, we want to have a demand forecast. But how are we going to get there? Well, we're going to need some sort of time series aspect to it. So we start to add to this app, we add a time series plot using Plotly, ggplot2, dplyr, and lubridate for the time series. So ggplot2 makes the actual visualization. Plotly converts it into an interactive visualization, but dplyr and lubridate are needed to be able to manipulate the time series, so that way when the user clicks on any of these buttons, it changes the aggregation level. So if they click M for monthly, it's going to be at a monthly level. If they click W for weekly, they're going to have 52 points in every year, and that's going to be a weekly level, daily, and so on. The button set here is again using this technology called Shiny. Okay, so then what we start doing is we start adding more and more complexity to our application. So here is an example where we're adding some value boxes up here. And what this is allowing us to do, or the users to do, is to be able to get kind of high-level insights and mainly warnings when things are going wrong, or green for everything's okay. And then we're adding more complexity from this standpoint, because as we add more things here, we want to not prevent the app from updating automatically. So we have some more logic. We add an apply button, which when we click the apply button, it drives this box up here that's just been added, the time series, the geographic plot, and so on. And then when we click the reset button, it resets everything. So it's no longer being driven by these buttons, but now it's being driven by this button here. So there's a flow and a reactive logic that we have to be able to and be comfortable with working. And that comes from Shiny. Okay. And then we start doing more things. We start customizing the CSS, which stands for custom style sheets. And we have to be confident working with HTML and CSS in addition to the R frameworks. So you can see these buttons are now blue. We've got a logo up here. The fonts have now changed. So this is actually a different custom web font. These fonts are now different fonts, and so on. And these are all green now, so you can see it matches the theme. Mainly, the reason that we do this is because we want that theme to look like our organization, because especially if you have a customer-facing app, or even an internal app for that matter, you want it to match the brand appearance of your organization. Otherwise, it's going to throw people off. And then we also have a custom dark mode, which I think I showed you, where we click the button in the bottom and it changed everything over to black, and now we have a green nav bar. And this just gives a little bit of fun for the user to have to be able to play with your app and customize it if they prefer a dark mode over a light mode. And then what we do is we add the machine learning. So now that we've got an app that we're pretty comfortable with, we start adding in some extra technology here, and this is the big win for the business, because then they can now forecast their demand, and that's utilizing technologies like Parsnip and XGBoost under the hood. Okay, so all of what we've just talked about is actually part of the learning process that I teach my students how to do in this new course that we just launched this past weekend called Predictive Web Applications for Business with R. So what we just saw was one of the two apps that we built in that course. This is using Flex Dashboard, and this is the sales demand forecast app. And that's available at university.business-science.io. And we'll talk a little bit more about that later. But really, it's a very good course that if you're interested in building what I just showed you, then that's going to streamline your process, and you're going to be able to learn it in just a couple of weeks. 80/20 tools. So high impact software. And I'm circling back to kind of where I started with. So when we learn data science and where we want to end up with is these predictive web applications, which is what's going to generate the business value for our organizations, this is kind of the tool set that I recommend that you learn. And this is actually what I teach. It's to be able to come through that integrative workflow, that data science workflow, but being able to integrate the tools into it. So you're not just learning one tool, you're not just learning, how to do a linear regression, one concept, but really it's how do you solve a business problem. You're not just going to use one tool, you're going to use probably 15 or 20 tools. And you can see that when we solve one problem, we're probably going to hit many of these different technologies. We may not hit all of them, but if you're ending up with an app, you're certainly going to hit a wide range of tools. So what we need to understand is how do we learn these tools and how do we bring things into production, which are through building these web apps. How are we going to take our data science into production? So the way that you do that is by learning the tools, and it's a lot like climbing a hill where you start at the bottom, and that's just, learning the foundational things first, learning things like data manipulation, learning how to work with text, with time series, with categorical data, learning how to make visualizations, learning how to make interactive visualizations, which are critical to your long-term goal, which is building web apps. Then you get to a point where you start moving into more of the advanced materials, which is machine learning. So now that you're confident working with data and visualizing it, you're then able to really apply some of the high-end tools that are going to solve some major business challenges. So you learn things like H2O, like Lime. You learn things like Parsnip for interacting and modeling with XGBoost. You learn things like Recipes, which is a great pre-processing library for taking your data set that's not well suited for machine learning and getting it into machine learning ready format. And then once you get that to that point, you're then ready to start thinking about building web applications and distributing. And that's learning technologies like Shiny and learning technologies like R Markdown. So this is kind of that hill climb, but I have good news. You can really accomplish this a lot faster than what took me. And you can do it in weeks, not years. It's not going to take you nearly as long as it took me. The courses and the learning plans, this is the things that I've developed personally to help students just like you, to help people like when I was starting, what I wished I had. And it's really a system that's well developed and it's proven now. We've had over 600 students in it, and we've had many, many success stories. And it's really working for people just like us. So the thing that I want to circle back with in this section is the two most marketable skills is learning machine learning and web applications. So we know that those are the two most marketable, but you have to kind of go through that process of learning some of the other foundational skills as well through kind of a problem-solving approach, a project-oriented approach, which is what works most effectively. So what I'm here to tell you is the system gets you to where you want to be in order to have those marketable skills, both machine learning and web applications. In fact, that's the course that I just released. That's what we're doing. We're showing you how to build web applications using machine learning. But there is a roadmap and there's a method to our madness. So it all starts with these three courses that we have. We've got the first course here, which is Data Science for Business 101. And what that teaches you is the foundations. That's a core. That's kind of your core program where you're learning most of things like the tidyverse. You're learning machine learning with Parsnip, but more at a foundational level. Like, what does that algorithm mean? How do you use it? What are the key parameters in XGBoost that I have to change and tweak and be aware of so I don't get myself into trouble? And then also, how do I convert that into a product, meaning a business report? So you learn that in the 101 course. Then once you get that basic foundation of machine learning and some data science tools that you're confident of working with based on the projects that you've completed in that course, then you're ready to move on to the 201, which is where you really start to accelerate your learning. So you start to go from just learning the foundations to now being able to accelerate and get into the advanced machine learning things like H2O, learning things like recipes, and learning things like Lime for feature importance. and all of the tools that really generate millions and millions of dollars of value for your organization. So that's what's learned in the second course. You also get a repeatable framework, which is something that is very important when you're doing data science, is to have a process that you can actually step through and apply to the bulk, the vast majority of your projects. So having a repeatable framework is very important. That's helped me a lot in consulting, and it's helped a lot of the students that I have that are either consultants or data science within business that need to be able to have repeatable methodology for their projects. And then you move into the web applications, which is the end product, that data science product. And that's really where you take all that foundational tools that you've learned already, and you start to be able to distribute them through your analytics products. So this is just a few more details about the courses. Again, the 101 does about 8 hours of machine learning. So this actually has a ton of machine learning baked into it, but it's a lot of foundational information like clustering, like regression. There's multiple challenges in this week. You also get 25 hours of data manipulation, time series, text, categorical data, visualization, and several challenges in there as well. And then you also get reporting, business reporting, and you'll actually complete 2 projects in that course. One is a product pricing algorithm, and the other one is a customer segmentation project. The second course is the 201. This is the advanced one that I was telling you about, where you really ramp up your skill sets. And what we're teaching here is it's one singular project that saves the organization about $5 to $10 million per year. And it's a churn project where the company that you're working for is losing employees. It's having a high churn rate, and we call that employee attrition. So you will develop, and you go through the entire process step by step of developing a machine learning algorithm, and more importantly, a return on investment analysis at the end of the project that integrates what you're learning from the data science end, but to actually providing a return on investment for your organization. You'll learn tools like H2O for modeling churn, machine learning performance, like learning AUC, lift, gain, all of the different measures for churn performance. And then you'll also learn how to explain what's going on and what the model's seeing using this package called Lime. So it's a very good course. And then once you do that, you pretty much have a full set of skills. Now it's just kind of taking those skills and then putting those into a final product, which is a web application. So that's the course that we just released, DS4B 102-R. It's web applications. We have a framework, and you're going to build 2 different apps. You're going to build that sales dashboard that we saw, and then you're also going to build a predictive pricing application as well. So those are the 3 courses. They're getting a ton of results, and these are actual comments, testimonials from students. And I, this is exactly what I wanted to happen when I built these courses, was to be able to impact people that are in our shoes, that were struggling before, that were having a difficult time connecting data science with the business. And also, I wanted to develop a system that really allowed people to apply the tools and training that they're learning very quickly. So this is the validation that I'm getting out of that. And these are real people. Rodrigo, he's a high-end data science consultant. He cut his projects down 50% of the time, which basically doubled his return on investment, made him twice as productive, and he's able to churn out more projects for clients and give them better response time. So it's a win-win for him. So he's driving up revenue for his company, and he's also satisfying his clients even faster than what he was before. This is Adam Mitchell. He has just started the 201 course, which is the advanced course, and he's already able to apply H2O to his current projects, and he's really excited about it. And then this is Mohana. He's working in a team where he has a lot of Python counterparts, and he's learning R in the tidyverse, and he's finding that he's able to get things done 10 times faster than what he was, and comparatively, he's got a higher quality of his work. and he's also being able to produce things much faster than his peers. So these are all examples of our students, my students, achieving results that matter to the business much faster and being more productive than what they were before the courses. Okay, so at the end of the day, I want to give you guys a gift. I want to give you guys something, a promotional code that knocks 20% off of the price for the courses. These are, again, these courses, I designed them for people like you, for people like me, when I was starting out, that wanted to get up to speed as fast as possible. So this is the series of courses. We've got a bundle here, which is the 101, the 102, and the 201. So this is the foundations, this is the web development, and this is the H2O advanced machine learning that's available in this bundle here. If you use this Shiny Apps launch promotional code, you'll get that for $919, which is about $378 below if you were to purchase these courses individually without the code. The other thing too is I realize that $919 may be a bit steep for a single purchase, so we do have payment plans as well. And if you're, depending on what your budget is for education expense, if it's $100, if it's $200 a month or $400 or whatever it is, these are different plans that are designed to fit into those budgets. So again, if you use the Shiny Apps launch code, you can get them for the courses for the price that I have here. And there's these different payment plans as well. So at this point, what I would love to do is take any questions that we may have from the audience. Unfortunately, I can't see what's going on, but I assume that there's some questions out there.
Yeah, I've been answering a lot of them. So we actually been having some fun conversations on the side. One question from Lewis: if you're already enrolled in a course, do the codes apply, the coupon codes?
Yes, and actually, Lewis, reach out to me personally, because I'll talk with you about what your options are if you're already enrolled.
Okay. Another question is, well, of course, we always get this one, the R versus Python, but the question is, can you speak on why R is better for analytics than Python? And we actually have a whole article on this.
Yeah. So there's an article that's out there called six reasons for R for business.
I'll link it.
And it's a really good article that outlines a lot of the reasons that I found R to be more useful than Python for me particularly. At the end of the day, everyone's different, and there's a lot of factors that are out there. Some may be, saying like if most of the people that you're working with are using Python, then you should use Python. But then I also have plenty of examples where there's one R person in a group, and that person is just way more productive because they're using tools like the tidyverse and so on that are a little bit more developed than pandas for Python, and they're able to get work done a lot faster. At the end of the day, R versus Python, choose what you feel most comfortable with. I'm most comfortable with R. I like it because of the tool set that RStudio has been leading the industry with. And they're an excellent example of why I love R, because they're building all of this free software like the tidyverse, like Shiny, like all these packages. Whereas in Python, it's kind of the Wild West where you have some different people. And it's all open source contributors, and they're doing a fantastic job. But it's just there's not one organization that's leading the pack. RStudio has developed the IDE as well, so it's just it's one company that's providing a consistent series of tools that are free to use. You can't beat that, and they just work, and they have like 70 plus developers that are developing these tools as well. So they just keep getting better and better.
Okay. This was a fun question. A guy asked, can you do the course in a couple of days?
And we've had one person do that, and I don't know how their job let them do that, but he flew through the course. I've never seen anyone. I think he completed the first two courses in like 2 or 3 weeks. And I know he definitely skipped some lectures, but
Yeah.
yeah, to each their own. Your job
Yeah.
will have to give you the latitude to be able to accomplish that, because it's going to take you. The first course has 35 hours of videos, and that doesn't include any of the free time for you to complete the challenges and everything.
Yeah, and that's what I was going to say. Like, it is a lot of videos, and the information is really good. And the best way to go through the courses are to have the video playing and then code along with
Yep.
the video, so you can pause and you can see what's going on, and you really learn the sort of sequence of doing working through data problems that way. So I mean, you can blow right through the videos and just, if that's
Yeah.
the way you like to learn. But I
Yeah.
think most people would get a lot more out of it if they code along.
Yeah, what you get out of it, what you put into it. The courses will, I mean, they're hands down, they're getting, awesome results for everyone who's taken them. The key for me is, they're kind of designed to code along with me as I code. Like, you'll actually see me coding, and then you kind of repeat what I do, because that locks in your muscle memory, and that's how a lot of people learn programming. But just, I would say, do it how you want to do it, and if it's effective and if it works for you, that's great.
Yeah. I think that might be about it.
Okay. All
Yeah.
right. All right. Well, I appreciate everyone for listening to this. Again, it was kind of a personal story there at the beginning, but I really wanted you guys to understand where I'm coming from, why I'm doing what I'm doing, and how that relates to this next evolution of data science, which is the role of the full stack data scientist. So
Yeah.
I really appreciate it, everyone. Again, we've got this Shiny Apps launch discount code. It's only good until, I think, the end of next week. So if you're interested in any of the courses, you can use it for that, and it'll get you 20% off. So definitely use it, but do it within the next couple of days, because otherwise it'll go away.
Awesome. Thanks for everybody for joining. This was a lot of fun, and hope you guys got some value out of it.
All right. Thanks, everyone.
All right. Take care.
All right. Bye-bye.
Bye-bye.